Hello friends, today our topic of discussion is Euler method. So in this method, we have to solve a problem of differential equation. And the differential equation is taken as d over dx of xy with initial condition yx0 is equal to y0. And this curve is showing that at this x0 point y0 coordinate is given and we have taken a tangent. And through this tangent, if we move one step forward, means we take x1 on x-axis and corresponding value of y is y1, then it is getting as p1. So if we join p0 and p1 and apply these points to find the slope, the slope of tangent is taken as y1 minus y0 upon x1 minus x0. This is equal to value of the function at p. So we are assuming that p0 is known to us as given in the question. So this is the obtaining, and y1 equal to y0 plus x1 minus x0 upon x0 y. So we have taken here x1 minus x0 is h, that is we have taken this increment in x0 and we have taken these points equally spaced as it is x1 x0 plus h, then x2 is x0 plus 2h. In this way xn is equal to x0 plus nh. So observing this, we get y1 equal to y0 plus h times value of the function x0 y. If we want to calculate for y2, it will be y1 plus h times value of the function at x0 plus h y1. And similarly up to so in this way we can calculate the general formula, that is yn equal to yn minus 1 plus h times value of the function at x0 plus n minus 1 times h, comma yn minus 1. So this is the formula which we use in the questions. As we have discussed the Euler's method, and the problem is this as dy by dx equal to x plus y square, and the initial condition is given as y equal to 1 and x equal to 0. To find an approximate value of y at x is equal to 0.5. So first we have to think that what we have to take the step size. So h should be here a small quantity. So to find at x is equal to 0.5 and using this differential equation, dy by dx equal to x plus y square. With initial condition y at 0 is equal to 1. So let it be 1. I am taking here the step size h equal to 0.1. So by taking this 0.1, we can go in this way. First it is 0, so it is x0, then x1, 0 plus h, that is 0.1, then x2, 0.2, then x3, 0.3, that means this gap is 0.1, x4 is 0.4 and x5 is 0.5. So we calculate their values. So this is set for x. Formula we have is yn equal to yn minus 1 plus h times value of the function at x naught plus n minus 1h by n1. So as we will substitute n equal to 1, we will get y1. If you put n equal to 2, we will get that means we have to go up to for 1, 2, 3, 4 and 5. So we will substitute 5, it will be this 4. So we are observing that if we put y1, we will use y1. If we put y2, we will use y1. In this way, this can be done in the table format so that it makes easy, and there we consider the steps of Euler math. So table is x, y, dy by dx, and this is equal to x plus y square, and Euler's formula is, so we have taken here Euler's formula, which is yn equal to yn minus 1 plus h times value of the function at the points which we will take here. So first we come to the point which is initially given, that is 0. Then we have 1 at this is 1, y we have 1, and then dy by dx will be calculated here 0 plus 1 square. So this is equal to 1, and now substituted in this formula. So first, this is first step, so it is y1, and y1 equal to, using y0 is 1 plus h is step size we have taken 0.1, and value of the function is calculated here. So this is y1, and the result is 1.1. Now we come to the second step, in which we have taken an increment 0 plus 0.1. So it is y1 is 1.1, which is obtained from Euler's formula, and this is 0.1 plus 1.1 square. So calculate it. This is equal to 1.31 using the calculator. So y2 can be obtained in this way. So this is y1. y1 is y2 is equal to 1.1 plus 0.1 is fixed, and here it is 1.31. So when we calculate it, this will be obtained as 1.231. And the next step is 0.2. So at this, it is obtained as 0.2 is x2, and y2 is calculated 1.231. So using here, and this is 0.2, which is correct, and 1.2314y in this square, and this will be calculated and taken up to 4 decimal places. So it is 7154, and now y3 will be obtained. So what is y2 here? For previous value we have to use. So y2 in this row is 1.231 plus 0.1 is the value of h, and this is function value at the particular point. So if we calculate it, y3 is 1.4025. So now taking the next step, so this is next step is 0.3, and this is 1.4025. Now it is 0.3 plus 1.4025 whole square. So after the calculation, it will become 2.26701, and then y4 will be obtained from these points. So it is 1.4025 and 0.1 is h, and this value is 2.26701, and simplifying, this will be 1.6292. I have taken it up to 4 decimal places. Now 0.4. 0.4 is 1.6292. So this is 0.4 plus 1.6292 whole square. Calculating this, it is 3.0543, and obtaining y5 here. So 1.6292 plus 0.1 multiplied by 3.0543. So this is equal to 1.93463, and so at 0.5, y5 is obtained as 1.9346 up to 4 decimal places. So this is the value of y5, and we have to obtain the value of y5. So this is done by the Euler formula, and this table has made all the things easy, and very clearly it is done.